Welcome back to another sparkling episode of our gemological get-togethers, also known as our Encyclopedia of Precious Stones. We are continuing our slow but steady dive into the fascinating world of pearls. Today, I and the company owner Konstantin are taking you with us on video to a real working pearl farm. You will get a behind-the-scene look at the industry, see what the daily grind looks like, and discover that, yes, oysters have health checked up too. And they can get sick very easily, in fact. We will get into the details later, but here is a short version. At almost every stage of cultivation, around 25% of oysters die, and with today's environment challenges, the loss can be even higher. That's one of the reasons genuine pearls are so valuable. From previous episodes, you will remember that the supply of high-quality pearls is shrinking every year. For example, a year and a half ago, when I trained in pearl selection and grinding on Lombok, Indonesia, there were only 5 active farms left out of original 50. Since then, 2 have closed. The reason? Bankruptcy. Driven by declining ocean water quality, weaker oysters, and inevitably poorer pearl quality. Lombok itself is gorgeous, by the way, lush nature, turquoise waters, but one travel trip. Choose your hotel location carefully. The island has many mosques, and the call to prayer is amplified. I mean, really amplified. It reminded me of a trip to Africa where once we walked to a Christian choir singing from 7 a.m. to 2 p.m. non-stop. But that was just one day. Here in Lombok, imagine a muezzin practically standing over your bed with a megaphone every single day. But never mind. Our training there is still ongoing. I've only spent 2 months on the farm so far, which is just scratching the surface basically. To become a true pearl specialist, you need years of study. Thankfully, our company has people who have spent 6 years mastering the craft, backed by certifications. I am just peeking through the door to this treasure room of knowledge, but I'll get there. Tahiti's black pearls are also on our future initiatory 100%. Now let me pass the word to the owner of the company who kindly made a very detailed video during his last visit to Lombok. Let's dive in.
Okay, a quick detour. See those 3 tiny islands out there? 1, 2, and 3. That's the Gili Islands. Lots of expats live there, including Russians, Ukrainians, and Belarusians. The vibe? Think stick enlightenment, do yoga, maybe double in party extras and magic mushrooms. In short, they got their own little scene going on there. The biggest island is so tiny, you can walk it in about 15 minutes. It's surprisingly crowded for such a small place. Clearly, the atmosphere has its own pull. Next, a coffee stop just to show you how busy it gets here. Tourists everywhere. And the cafe music is phenomenal. We spent months sorting through hundreds of thousands of pearls, learning what's good, what's flawed, and what drives value. No pearls were allowed outside of the lab, so sorry, forgive the video quality. But at least we can show you how the process is going on actually. How do you get those precious pearls in your hands? Alright, back to the process. This pavilion is basically a scientific lab. Microscopes, reagents, the works. They run everything on seawater, as you can see. When they pump water in, tiny marine fish sometimes come along for the ride, so they keep them here temporarily. When the tanks are drained, the fish flow back out, instant freedom. Look, here is another little fishy here. The fact that the fish are alive and well is a good sign that the water quality is exceptionally clean. So in this specific hatchery, only one oyster species is bred, and the age of an oyster can be guessed from its shell. By the way, the rim of the shell, the color often matches the eventual pearl. So if you have a white rim, expect a white pearl. A golden rim, most likely a golden pearl. Tahitian oysters, for example, have green-black rims, given their famous dark tones. How does the breeding occur? So it starts by selecting the healthiest adult oysters. Of course, we start with checking the gender, and then we pair the strongest 20 oysters for spawning. From 20 oysters, they can get 150 million larvae. At first, they are microscopic, just like dust in the water, and they fed plankton in tanks. Then given fine mesh panels to attach to, like tiny sugar grains. And later, they're wrapped in protective mesh and moved to the ocean at 7 meters deep. The survival rates are brutal. From larva to settlement, it's 15% survive. From settlement to ocean transfer, another 15-20% survive. That's why millions of larvae are needed just to raise thousands of oysters. Alright, now we are heading into the next room, and this is a fully operational lab. They're used when draining water from the larval tanks. The water is changed every few days, and the nets make sure that the baby oysters don't get washed out to the sea with it. The mesh is so fine it's practically like fabric, you can barely see the openings. Next stop, the cool room. I would say it's about 15 degrees in here, which is perfect temperature for plankton cultivation. Inside, it's like pure laboratory again, microscopes and all that kind of stuff. Here is how it works. They prepare distilled filtrate water and seed it with plankton cultures. If the water is crystal clear, like in this container, it means that the culture was just started and the plankton population is tiny. The darker the water, the denser the plankton, meaning it's been growing longer. And this blackish container, that's a super high concentration, premium grade plankton, oysters fine dining at its best. Then this plankton feeds the larvae until they're ready for the ocean. Once they're out at sea, they switch to self-feeding in the wild. Next up, the microscope station. If we look here with the naked eye, we see basically nothing. Well, maybe a bit of dust, but that dust is actually microscopic oysters, already with fully formed shells identical in shape and structure to adult oysters, just on a miniature scale. See these ones with something inside? They were alive but have since died. Placed here just for demonstration. The empty shells are the ones that didn't make it. The team randomly samples a bit of this dust to check survival rates, counting how many are alive and how many have died. And sometimes an entire batch perishes, usually because of some hostile bacteria. Other times, survival is good. If those 50 or 20% survive long enough to be transferred to the ocean, that's already considered a huge success. And here is what they look like when they are ready to head to the sea. This batch is already dead, just for illustration. At this stage, each baby oyster is only about 1/10 of a millimeter in size. Once they reach this size, they are placed on mesh panels and moved into the ocean. Okay, these here are about 1.5 to 2 months old. Their shells are still soft, but they have managed to attach themselves to surfaces. And if we look at survival from the start, we have already lost 90% of the oysters. They often settle in clumps of 2 or 3, and it's an instinct to live in colonies. Unfortunately, that's bad news for growth because some won't get enough food or none at all. That's why they are regularly pulled up and cleaned. They are so delicate at this age that you can't scrub them with a brush to remove parasites. They are rinsed gently with a stream of water. After all, they are separated and reattached individually, so each gets enough to eat. Of course, some still crawl back together in pairs, like these two here, social little creatures, but their friendship can literally starve them. These ones here are about 3 to 4 months old, and those ones around 6 months already. See how quickly they have put on size? Once they are released into the ocean, a few months later they reach this scale, and clearly they have been eaten well. By the 6 months mark, their shells have hardened enough to feel properly firm. And around this time, they start growing these little hair-like threads. Here, let me show you. Which they use to anchor themselves permanently. After that, they can't crawl away anymore. As they age, these threads become thicker and denser, locking them securely onto whatever surface they have chosen. That also is called a beard. By the way, how old is this one? Oh, okay, this one is 1 year old. And they're all alive and well. They have just been pulled out for cleaning. Could you please put your hand here for scale? Perfect. Now you can see the size compared to a hand. These over here are about 1.5 years old. And these, around 2 years already. They grow surprisingly fast. And when do you start nucleation? At 2 years?
2 years, yeah.
Exactly. Once they hit the 2 year mark, they are ready for the nucleus insertion. We are about to show you how that's done, by the way. I saw, by the way, an oyster with a broken shell, so I asked the guys who work here, like, what will you do with it? Is it dead already? But they said, no, she is just sick. Normally, the shell would be tightly closed, but she is weak right now. And they will move her back to the lab, keep her in a comfortable environment, and she might recover. They will wait and see. And here it is, the nucleus we are going to implant. By the way, a fascinating fact. After countless trials and errors, pearl farmers discovered that the best material for a nucleus, the one most likely to be accepted by the oyster and coated with a nacre instead of being rejected, is a bead carved from a freshwater mussel shell found in the Mississippi River, USA. That's right, the whole world uses this. The mussels are farmed there, the beads are caught, and they're exported globally. Also, with the bead, they also insert a small piece of mantle tissue from another oyster. This means, unfortunately, one oyster has to be sacrificed, because we need a tiny piece of its living tissue for the process. So, the oyster we just opened, the part we take is this transparent mantle tissue right here, not the black parts, this oyster natural filter. And in the wild, if sand or any foreign particle gets inside, it gets trapped in this filter area. Then the mantle tissue secretes the same material as the shell, nacre, to coat the irritant forming, and we are going to use the surrounding transparent tissue. The black filter parts aren't suitable, as I said, because they're just for straining plankton. So why do we need the mantle tissue at all? If we just place the bead, the nucleus, into the oyster, it will simply spit it out. The oyster recognizes it as a foreign body. But if we wrap the bead in a tiny piece of another oyster's mantle tissue, it fools the host. Now this is like part of me, so it keeps it inside and begins coating it with nacre. Of course, even then, success isn't 100%. About 25% die immediately after the operation, and another 25% die later during the pearl's growth. So in total, roughly half don't survive to harvest. And even from the survivors, only about 10% of pearls are of average commercial quality, and 1% or less reach high-end jewelry-grade perfection. As the kind lady explained to me, from one sacrificed donor oyster, we can cut 10 to 15 pieces of mantle tissue, enough for the same number of host oysters. These species can be used for up to 8 years, and in that time, it can undergo 3 to 4 nucleations. After that, it can no longer produce pearls, so it's either discarded or eaten. I asked if they sell them to restaurants, but here in Lombok, locals and Indonesians in general don't traditionally eat oysters. They're not considered food. A few farm workers might eat them, but not with much enthusiasm. So in some countries they are a pricey delicacy, and here not so much. So generally they eat what they can and the rest just discarded. Now we are cutting the tissue into smaller pieces and we are ready for the next step. This is a very, very fine and delicate operation. And now what do? We have to put the pieces of tissue together with the bead, right? Yeah. So we remove all unnecessary parts because a poorly cut piece of tissue can affect the pearl's eventual shape. Clean cuts mean better pearls in this case. And one tissue piece for one oyster, and we check that it's all clean with no debris, so to avoid any risks of failure. Now, the moment of truth, the implantation itself. This oyster is 2 years old. First, they inspect it to make sure it's healthy. Like people, oysters can be strong or weak, healthy or sick, and the light is shown inside to examine it. First, he opens up the filter. Yes, let me shift the angle so you can see better. This particular oyster is a male, but that doesn't matter when it comes to pearl production. Gender isn't a factor. A very small incision is made with a special scalpel, and the nucleus is inserted. But I see the problem. This oyster turns out to be very firm inside, and the bit won't go in properly. They try again, but then we see why it happened. Its parasites are living on it, and it's sick. From the outside, it looked fine, but inside, it's unfit for use. So, have to swap in another oyster. This time, the incision is made with a special spoon-shaped knife. The bit goes in smoothly, and you can even see it sitting inside. Next, a small piece of mantle tissue from the donor oyster is placed over the bead. This is where a GoPro wouldn't cut it, so no zoom. So I am filming it on my phone. And another piece is added for security. The third is removed and replaced to get it just right. And that's it for the oyster. It goes back into the sea where it will grow its fur for 2 years. Farm work never stops, by the way. Every month or 6 weeks, the oysters are pulled out, cleaned, sick ones are removed, dead ones discarded, and parasites scraped off. Rain, storm, cold, doesn't matter. The work continues year round. Now, let's check one that had a nucleus implanted 2 years ago. A fresh incision with a different scalpel here, and there it is, a pearl. So, we have waited 4 years for this moment. While the oyster is 4 years old, the pearl is 2 years old, and the color, a nice steel gray with a hint of pink, I would say, but unfortunately the quality is not great. That one is the third grade. A disappointment after 2 years of waiting. And here is the reality. Less than 1% of all pearls come out perfect. Most are like this. And here is something I didn't know before. If an oyster produces a poor quality pearl, it won't be used again. Experience shows that it will produce the same low quality every time, no matter how perfectly the bead is placed. So this one will be eaten. If it had produced a good pearl, they would immediately insert a new, larger bit in the same incision because the oyster itself has grown bigger and can handle it. In that case, no new mantle tissue is needed. Once implanted, the oyster rarely rejects future beads. For comparison, here is nucleus next to the harvested pearl. If left in the oyster for another 2 years, nacre would double its thickness. That's why, when it all goes well, they can get a 50 or so success rate for commercial quality pearls. One thing I really like here, look at this guy's office. He's sitting outside in warm weather with a view straight onto the ocean. Imagine having a job that's delicate, precise, and scientific, but right on the shore of a tropical sea. Over there, another worker is doing its inspection. Plenty of stuff here. I can see their little house where some are relaxing, probably on a lunch break. And every single day, in the same rhythm, hold the oysters up, clean them, seed them, hold them up again, clean, seed, repeat. No weekends, no holidays. Pearl farming runs 376 days a year. The weather right now turns perfect for my favorite tropical moment, a sudden heavy rainstorm. The farm crew came to pick us up, and now we're heading out for the team that handles daily maintenance. This floating base is where the oysters are pulled up. Many are so heavily encrusted you can barely see the shells. They're covered with corals, seaweeds, parasites, and even predators that feed on the oysters. Sometimes coral colonies grow right over them. Fascinating. I could spend hours with a magnifying glass here. Look, there is a little crab. So adorable. The tropics really are bursting with life. And the workers scrape everything off with small knives. That helps the oyster grow. As you can see, the work is daily. Today it's one batch, tomorrow another, the day after a third, and it's an endless cycle. You can see more crew are doing the same work further along. And now we have reached the farm itself, and it's storming out there. Also slow to see, that's the farm's oysters lines. We might be pulling up some for cleaning or maybe just position for now. The rain is pouring, but it's warm, so the wind is warm too. The waves aren't big, so it's pretty nice actually. Now the cleaned oysters are placed in mesh bags and lowered back into the sea down to 7 meters. At this stage, there is nothing lab-like about the work. It's just about tying good knots to the bag so they don't sink into the seafloor. Tie them, drop them, and done. There are plenty of floats around here, and for context, this is considered one of the largest farms in the region. Still, there are probably only a few thousand floats. I expected the scale to be much bigger. Now we move a bit further out and start hauling up another line. Turns out I had misunderstood earlier. They don't clean once every 2 years, they clean every 6 months. When I said 2 years, I meant the age of the oysters, not the cleaning schedule, sorry. So every 6 months, every line gets pulled and cleaned, and the gross is tossed into a pile for now. The detailed cleaning comes later. And the amount of sea life is just incredible. Crabs scuttling everywhere, creatures swarming over every surface. And here is an interesting part. Pearl farming doesn't harm the environment. Quite the opposite, actually. It creates more habitats for marine life. All the growth scrapped off the nests goes right back into the ocean, effectively increasing the living space for countless species. And that's pretty much amazing.